Good morning, students. Welcome back to our software engineering class. We are discussing about object-oriented software designing. In this class, we are going to discuss about the design concepts, especially module level design concepts of object-oriented systems. In a object-oriented system, the basic module is a class. During design, the key activity is to identify and specify the modules that should be there in the system that is being built. The goal of the design activity is to create a design that is correct and has attributes that make it a good design. These are the expectations of a module. There are many desirable attributes for an object-oriented system. Mainly, we are going to concentrate on three concepts that govern the quality of your design and improve the design. These three concepts are this coupling, cohesion, and the open-closed principle. First, we see about this coupling. This coupling has been introduced in the function-oriented design also. As I told in the function-oriented design, coupling is an inter-module concept which captures the strength of interconnection between modules. How two modules are related, how strong they are connected with each other. That is decided by coupling. The more tightly coupled the modules are, the more dependent they are on each other and more difficult to understand and modify them. Low coupling is desirable for making the system more understandable and easy to modify. The degree of coupling between a module and another module depends on how much of information is needed about the other module for understanding and modifying this module, and how complex and explicit this information is. Low coupling occurs when this information is as little as possible, as simple as possible, and it is easily visible and identifiable. There are three types of uh, coupling exist between modules in the object-oriented systems, namely interaction coupling and component coupling and inheritance coupling. Interaction coupling, uh, component coupling, and inheritance coupling. Let us see what are these three couplings are. Interaction couplings occurs due to methods of a class invoking methods of another class. The worst form of coupling here is If methods directly access internal parts of other methods, this is not encouraged. Okay. Coming to interaction coupling, this interaction coupling reduces if methods of a class interact with the methods in another class by directly manipulating instance variables or attributes of objects of the other class. This form of interaction is also not discouraged, is discouraged, as one has to understand the code of other classes to understand what changes they are making to the class. Also, it violates the encapsulation principle of object orientation. This form of interaction is worse, very bad, if variables are used to communicate temporary data. That is, the variables are used not to hold the state of the object but to pass state of the computation from one object to another object. Coupling is least if methods communicate directly through parameters. Within this category, coupling is lower if only data is passed, but is higher if control information is passed, since the invoked method impacts the execution sequence in the calling method. Coming to this component coupling refers to the interaction between classes where a class has variables of the other class. Again, I tell you, component coupling refers to the interaction between two classes where a class has variables of the other class. There are three situations exist when this can happen. A class C can be component coupled with another class C dash if C has an instance variable of type C dash, or C has a method whose parameter is of type C dash, or if C has a method which has a local variable of type C dash. Coming to this inheritance coupling, the inheritance coupling is due to the inheritance relationship between classes. Two classes are considered inheritance coupled if one class is a direct or indirect subclass of the other class. If inheritance adds coupling, then one can ask the question, why not do away with inheritance altogether? The reason is that the inheritance may reduce the overall coupling in the system. Coming to the cohesion. See, as you know already, coupling is an inter-module concept, but cohesion is an intra-module concept. It focuses on Why elements of a module are together in the same module? The cohesion in object-oriented systems has three aspects, namely method cohesion, class cohesion, inheritance cohesion. What are they? Method cohesion, class cohesion, inheritance cohesion. The method cohesion focuses on why the different code elements of a method are together within the method. The highest form of cohesion is if each method implements a clearly defined function and add all statements in the method contribute to implementing this function. Next, this class cohesion. The class cohesion focuses on why different attributes and methods are together in this class. The goal is to have a class that implements a single concept or abstraction with all elements contributing towards supporting this concept. In general, whenever there are multiple concepts encapsulated within a class, the cohesion of the class is not as high as it could be, and a designer should try to change the design to have each class encapsulate a single concept. Next, the inheritance cohesion focuses on why classes are together in a hierarchy. The two main reasons for inheritance are to model generalization specialization relationship and for reusing the code. Cohesion is considered high if the hierarchy supports generalization specialization of some concept. It is considered low if the hierarchy is primarily for sharing code with a weak conceptual relationship between superclass and subclass. The last design methodology is this open closed principle. This is a design concept coming into existence in the object oriented context. The basic goal here is again to promote building of a system that are easily modifiable. The basic principle behind this open closed principle is that software entities should be open for extension but closed for modification. That is the basic principle. A module using open for extension means that its behavior can be extended to accommodate new demands placed on this module due to changes in requirements and system functionality. The modules being closed for modification means that The existing source code of the module is not changed when making enhancements. This principle restricts the changes to the modules to extensions only. That means it allows addition of code but disallows changing of existing code. That's all about this open closed principle. Our next idea is this unified modeling language, UML, simply calling UML. Unified modeling language is a graphical notation for expressing object-oriented designs. It is used like for OOD, object-oriented design. It's a graphical notation. It is called a modeling language and not a design notation. Why it is so? Because it allows representing various aspects of the system, not just the design that has to be implemented. For a design, a specification of the classes that exist in the system might be sufficient. However, while modeling, during the design process, the designer also tries to understand how the different classes are related and how they interact to provide the desired functionality. So this helps in building designs that are more likely to satisfy all the requirements of the system. Some of the notations that we are using for UML, they are class diagrams, sequence diagrams, and a collaboration diagram. Class diagrams, sequence diagrams, and collaboration diagrams. We shall see them one by one. The class diagrams describe the classes that are there in the design. The final code of object-oriented implementation is mostly classes. So these diagrams have a very close relationship with the final code. Now, a class diagram defines classes that exist in the system, associations between classes, subtype, supertype relationships. A class is represented as a rectangular box which is divided into three areas. The top part gives the class name. The middle part lists the key attributes or fields of the class. The bottom part lists the methods or operations of the class. Coming to this sequence diagrams, the class diagrams represent the static structure of the system and how the different classes in the code are related. But they do not represent the dynamic behavior of the system. That is, How the system behaves when it performs some of its functions cannot be represented by class diagrams. This is done using sequence diagrams or collaboration diagrams, together called as interaction diagrams. An interaction diagram captures the behavior of a use case and models how the different objects in the system collaborate to implement the use case. A sequence diagram shows the series of messages exchanged between some objects and their temporal ordering. When objects collaborate to provide some desired system functionality, the sequence diagram is generally drawn to model the interaction between objects for a particular use case. It should be noted that in a sequence diagram, it is objects that participate and not classes. So, when capturing dynamic behavior, the role of classes are limited because during execution, it is objects that exist. Yeah, collaboration diagram also shows how objects communicate with each other. Instead of using a timeline based representation that is used by sequence diagram, a collaboration diagram looks more like a state diagram. Each object is represented in the diagram and the message sent from one object to another are shown as numbered arrows from one object to the other. That's all about this collaboration diagram. Now, how do we design using UML? The design methodology for producing object-oriented design using UML consists of the following sequence of steps, namely produce the class diagram, produce a dynamic model and use it to define operations on classes, produce the functional model and use it to define operations on classes, identify internal classes and operations, optimize and package. These are the sequence of steps used for designing object-oriented design using UML. The first step of this design is generally performed during the requirements phase when the problem is being modeled for producing the SRS document. The basic goal is to produce a class diagram of the problem domain. The dynamic model of a system aims to specify how the state of various objects changes when events occur. What is an event? An event is something that happens at some time instance. For an object, an event is essentially a request for an operation. So In the function-oriented design also, we saw the software metrics. I told you several times what is the meaning of software metrics. This object-oriented system also has a software metrics. It has a list of metrics, namely weighted methods per class, depth of inheritance tree, number of children metric, coupling between classes metric, response for a class metric, lack of cohesion in methods metric. Let me give the definition of all these metrics one by one. The weighted methods per class metric is defined as the sum of complexities of all the methods and gives some idea about how much effort might be needed to develop the class. Again, I tell you, the weighted methods per class metric is defined as the sum of complexities of all the methods and gives some idea about how much effort might be needed to develop the class. The depth of inheritance tree of a class metric is defined as the maximum depth in the class hierarchy of this class and can represent the potential of reuse that exists for a class and the degree of coupling between the classes and its parent classes. The third one, the number of children metric is the number of immediate subclasses of a class and it can be used to capture the degree of reuse of a class. The next one is the coupling between classes metric is the number of classes whose methods it uses or who use its methods. The next one, the response for a class metric is the number of methods that can be invoked by sending a message to this class. It tries to capture the strength of interconnection between classes. The last one, the lack of cohesion metric represents the number of methods pairs whose set of access variables have nothing in common minus the number of methods pairs that have some common instance variables. Again, I tell you, the lack of cohesion metrics represent the number of method pairs whose set of access variables have nothing in common minus the number of method pairs that have some common instance variables. So these are the metrics that we use it for object-oriented systems, and they are quantifiable measures that decide the progress of any activity. And they give some numerical value. So with this, we are finishing this object-oriented design. It's a very good design methodology to design software systems. So next concept is detailed design that we will see in the next class. Okay, see you tomorrow.